Good morning, dear students. Trust you're doing good. Today, I've decided to put up a comprehensive video because of the Form 4 students who are just joining us this week. So, in this video, we are having linear sequences, quadratic sequences, cubic sequences, and exponential sequences. Now, I would like you to pause at every point you think you don't understand and rewind. Go back and try and listen again because I want you to get everything very clearly. At the end of the tutorials, we're giving you some exercises which will be very important for me to evaluate how far you have gone and how well you understand. Alright, take care. Every linear sequence has the general term an plus b, where a and b are constants. If I substitute a value for n, it changes the value of an plus b. For instance, when I put n to be equal to 1, I would have a plus b. Okay? When I put n to be equal to 2, I will have 2a plus b. When I put n to be equal to 3, I would have 3a plus b. When I put n equals to 4, I will have 4a plus b. And when I put n equals to 5, I will have 5a plus b. If I write my results in a tabular form, I would have the table on the right hand side of that splitted working. Okay, now taking the differences between each terms, if I subtract a plus b from 2a plus b, I'm going to have a. Raising it out, 2a plus b minus a plus b. That will give me 2a minus a plus b minus b. And at the end of the day, I would have a. The same thing if I do for the second and third term, finding the differences, I will also have a. For the third and fourth, I would have a, and for the fourth and fifth, I would also have a. That implies that there is a common difference after getting the differences from each successive terms. Now, from this table, we know that a equals to the second term minus the first term. It could also be the third term minus the second term, or the fourth term minus the third term, or the fifth term minus the fourth term. But we know now that since a is common, we could just pick one of these results for it, which is why we picked second term minus first term. And that is why I wrote it to be a equals to t2 minus t1. And also, we know that when n equals to 1, a plus b will be the result. So that means that a plus b is equal to the first term, because n means the position of the term. So a plus b is equal to what? First term. And that implies that a plus b is equal to t1. t1 means first term, t2 means second term. Therefore, Tn means nth term. Now, from what we have deduced from the table we have there, we can create a special box where we'll put our results, which will be used in solving other problems. For linear sequences, nth term, where Tn equals to an plus b, it is important to note that a equals to t2 minus t1, which also means second term minus first term, and a plus b is equal to t1. Armed with this important results, we can proceed to find the nth term of the sequence of some examples. For instance, you have the first example there. Find the nth term of the sequence 4, 6, 8, 10, 12. If you look at it very carefully, this is a linear sequence. Why is it called a linear sequence? It is a linear sequence because the difference between each successive term is consistent. For instance, all I need to do is add 2 to a previous term to get the next one. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 2 is 10. 10 plus 2 is 12. And so on and so forth. So that implies that any sequence with a consistent difference, with a consistent pattern, difference on the first level, is a linear sequence. Alright, so using the formulas we deduced from the table, we have A to be equal to T2 minus T1. T2 is the second term, T1 is the first term, and from the question we are given, 4 is the first term, 6 is the second term. So 6 minus 4 will give 2, and that means A is 2. If we pick the second one in the box, A plus B is equal to T1, we can use that to find B. Of course, we already know what A is. If A is 2, then we can say that 2 plus B is equal to T1, and T1 is the first term. So 2 plus B is equal to 4, and we can get B to be 2. Putting these two results, A is 2, B is 2, putting both values into the general formula Tn equals to An plus B, we are going to be having our final answer to be Tn equals to 2n plus 2, and that explains the nth term of the sequence above. Now, Tn equals to 2n plus 2 is the right answer. Let's do a check. When n is 1, that will be T1 equals to 2 into bracket 1 plus 2. That implies that the first term equals to 2 plus 2, which is 4. How about when n is 5? That means T5 equals to 2 into bracket 5 plus 2. And that implies that the fifth term, which is T5, will be equal to 2 times 5 plus 2. And that is 10 plus 2, which will give 12. And looking from the question, we can see that the fifth term, according to the question, is 12. We have used the nth term to find the first and the fifth term, which shows that our answer for the nth term of this sequence is absolutely correct. Now let's take a look at the second question. Find the sequence, the nth term of 3, 10, 17, 24, 31, and so on. Using the same words, the same things we got from that box. A is equal to T2 minus T1, and A plus B is equal to T1. Okay? Simply say A is equal to 10 minus 3, because T2 is the second term and T1 is the first term. So A is going to be equal to 7. Now, putting 7 into the second equation, which is A plus B is equal to T1, you'll be having 7 plus B is equal to 3, and B is equal to 3 minus 7, and B will be giving you minus 4. So, now you've gotten the value of A to be 7, the value of B to be minus 4. Put them into the general representation of a linear sequence, which is Tn equals to An plus B. And that implies that Tn will be equal to 7n plus into bracket minus 4, and your final answer will be 7n minus 4. Now, this method is very simple because it has to do with just two things. The first is understanding that A is T2 minus T1. In other words, A is equal to the second term minus the first term. And we have A plus B to be equal to T1. These two things are very important for us to know. Now, let's go to the method, the alternative method for finding the nth term in a linear sequence. Going back to the previous questions, we can use the formula Tn equals to a plus n minus 1 into d. This formula is different, and the notations they are also different. For instance, here a is not t2 minus t1. In this case, a means first term and d means common difference. Common difference in the sense that the difference between each numbers must be consistent. So we can say the common difference is 6 minus 4, or 8 minus 6, or 10 minus 8, or 12 minus 10, of which all the answers will be 2. Now, knowing that the first term is 4 and the common difference is 2, when we slot these values into the formula, we are going to come up with an answer 2 plus 2n, which equals the answer we got in the first method. Also, for the second question, which we recently solved, 3, 10, 17, 24 and 31, as you can see on your screen, the first term is 3 and the common difference is 7. Okay, that implies that when we slot this into the formula given, we would be having 7n minus 4. I would like you to take your time to go through these workings again and again so that you can understand that which I have said. And once you're done, you can then turn to the next video. Okay, now we'll be dealing with a quadratic sequence whose nth term is given as an squared plus bn plus c. We should understand that a, b, c are constants. Okay, so when you do the value n equals to 1, you'll be having a plus b plus c. If you do it all through down, you'll be having different values. Pick these values and put them in a tabular form. You'll be having the table you see down there. Okay. Now, if you find the first difference, you will observe that the difference between each terms are very much unique. For instance, the second term minus the first term in a quadratic sequence is 4a plus 2b plus c minus a plus b plus c. When you do that, you'll be having 3a plus b, 3a plus b, and the same goes for each successive differences across the table until you do it again the second time. By the time you find the difference of the first set of differences, you'll be having a consistent common difference, which is where you stop. Now, 5a plus b minus 3a plus b will give you 2a. 7a plus b minus 5a plus b will give you 2a. The same applies to 9a plus b minus 7a plus b. That will also give you what? 2a. Now, from this table, we can deduce that 2a is the second difference. That is, 2a is the second difference. Of course, that is the common difference for a quadratic sequence. There's one thing about quadratic sequence which you should know. Every quadratic sequence always ends with a consistent common difference on the second level. Okay? The linear sequence ends on the first level. A quadratic sequence ends on the second level, while the other one which we'll be solving now, which is the cubic sequence, ends on the third level. Okay, so here the second difference is equal to 2a. Now, we also know that 3a plus b is saying the second term minus the first term. It's very glaring. 4a plus 2b plus c minus a plus b plus c will give us 3a plus b, which is why we say that the second term minus the first term will be giving us 3a plus b. And from this same table we can deduce that the first term is equal to a plus b plus c. Now, the things that we are getting from this table are very important for us to solve any quadratic sequence. Okay, they are very important for us to solve any quadratic sequence. When you are solving a quadratic sequence, you don't need to draw the table. If you can master these key equations, these key important tools, you'll be able to find the nth term of a quadratic sequence. Okay, what is the first thing you need to know? You need to know that 2a is equal to the second difference. You also need to know that 3a plus b is equal to the second term minus the first term. Also, you need to know that a plus b equals to the first term. With this, you have no problem. Otherwise, if you don't understand what to do, you can make this table again and deduce what you need to use from the table. Now, using the same deductions, let us now solve the problem. In the example below, I said find the nth term of the following sequence. We have 6, 9, 14, 21, and 30. Okay, the difference between 6 and 9 is 3, 9 and 14 is 5, 14 and 21 is 7, 21 and 30 is 9. You can see that the first differences are unique. We can also see that the second differences are consistent, they are the same. Now, this is where we bring in the values we have deduced, the equations we have deduced from the table, so to speak. Alright, so from knowing that 2a is equal to second difference, we can say 2a is equal to 2, because 2 right from what we have down there is the second difference. And from that we can say a equals to 1. Putting the value of a into 3a plus b equals to t2 minus t1, we'll be having b to be equal to 0, as you can see. And also c will be giving us 5, when we slot in the value of a and b into a plus b plus c equals to t1. We'll be having c equals to 5. Now, we know from what we have solved that a equals to 1, b equals to 0, and c equals to 5. Put these values into the general term for a quadratic sequence. You will be having 1n squared plus 0n plus 5, and that will be n squared plus 5, and that gives us the nth term for that sequence. That gives us the nth term for that sequence. Alright. Yes, a cubic sequence is in the form an cubed plus bn squared plus cn plus d. Again, a, b, c, d are constants. They are constants. Alright, as we have done in the previous sequences, when putting the values of n to be equal to 1, 2, 3, 4, 5, you'll be having these values. Of course, go through them and you will understand exactly what I've just said. Now, make that table. You would also have a deduction that on the third level, you would have a consistent difference. That table and the row where you have the third difference is where you have the consistent difference. So a cubic sequence will get to the third level, while a quadratic will only get to the second level. Alright, so your deductions from this table will be that 6a will be equal to the top difference, and 12a plus 2b will be equal to the first second difference. That's the first difference on the second row, which is 12a plus 2b. And you would have 7a plus 3b plus c to be equal to t2 minus t1. And of course you would have a plus b plus c to be equal to t1. Of course, we know the meaning of T2 and T1. T2 means second term, T1 means first term. Now, having these deductions, I collected them together and put them in a box as very important. Whenever you see they put a set of deductions in a box specifically, I'm trying to tell you that they are very important, and of course you should store them in your heart. You should put them to heart. Okay, an example is given in this page. Find the nth term of the sequence 2, 12, 36, 80 and 150. Okay, so by the time you find the first difference, according to what you're seeing right there, you would have 10, 24, 44, 70. The second difference will be 14, 20, 26, and the third difference, which is now consistent, will be 6 and 6. Of course, take what you have deducted from the table, your deductions. You would have 6a to be the third difference, and the third difference is 6. So that means 6a is equal to 6 and a equals to 1. Alright, you go to the next one. You have 12a plus 2b is equal to the second difference. So go to the second difference row. The first value there is 14. That's the second difference. So that means 12a plus 2b is equal to 14. When you slot in the value of a, which you have gotten in the first place, you would have b to be equal to 1. Okay, now go to the next one. You have 7a plus 3b plus c equals to t2 minus t1. That means 7a plus 3b plus c equals to second term minus first term. Alright, go ahead and slot in the values of a and b. Of course, you don't know the value of c, but you know that the second term minus the first term is 12 minus 2, and that will give you 10. And therefore, 7 plus 3 plus c will give you 10. 10 plus c equals to 10, and c will be equal to 0. Slot in the values now of a, b, and c into the last equation, which is a plus b plus c plus d equals to t1. Of course, you know t1 is 2 from the question. So you have 1 plus 1 plus 0 plus d will give you 2, and that means d itself is 0. Armed with these values, just put them into the equation. And when you put them into the general equation, I meant to say, for a cubic sequence, you would have having n cubed plus n squared as your final answer. If you decide to check this nth term to see that they agree with each of the sequences you are given as questions, you will find out that they are very true. For instance, let's do when n is 5. When n is 5, we'll be having t5 equals to 5 cubed plus 5 squared. 5 cubed is 125. 5 squared is 25. 125 plus 25 is 150. That means that the nth term for this cubic sequence is absolutely correct. And now we'll be talking about exponential sequence. An exponential sequence can also be called a geometric sequence, and you're expected to note the following points. Linear, quadratic, and cubic sequences will always deal with common differences. They are always dealing with common differences. If you observe very well, all we have been finding in linear, quadratic, and cubic sequences have been common differences. But an exponential sequence deals with a common ratio. An exponential sequence deals with a common ratio. Why am I telling you this? I'm telling you this because in the exams, nothing will be specified. You will not be told that this is a linear sequence or a cubic sequence or a quadratic sequence or an exponential sequence. It's your duty as a student to look into the question and decide by what you understand what kind of sequence you are solving. Alright. Now the second thing you should note again is that the mathematical operations involved in linear, quadratic and cubic sequences are usually addition and subtraction. They do not exceed addition and subtraction usually. And that means I'm talking of the basic operations between successive terms. For instance, if I have to do the difference between 3 and say 6, that's just 3 because I know that's 6 minus 3. Okay, so the mathematical operations involved in linear, quadratic and cubic sequences do not exceed addition and subtraction. However, an exponential sequence will always involve multiplication and division usually. Alright. The last thing you should also note is that the nth term of an exponential sequence is given as Tn to be equal to a times r raised to the power n minus 1. And of course, Tn as usual means the nth term, a means the first term, r is the common ratio, and the common ratio is gotten by dividing the second term by the first term. That's T2 over T1, or you can as well say T3 over T2. An exponential sequence has a common ratio in the sense that it is easily identified that the first term multiplies something to give the second term, or the first term divides a particular value to give it the second term. So it is not as bogus as the quadratic and the cubic sequences. Alright, n also depicts the position of the term. Okay, so we have some examples below. We are asked to find the nth term of the sequences 4, 16, 64 and 256. Okay, this is an exponential sequence, and going by what we see here, the first term is 4. The common ratio is also 4 because 16 divided by 4 is equal to 4. We can as well choose to say that 64 divided by 16 will also give us 4. And from what we have here, we put these values into the formula we have. We'll be having 4 times 4 raised to the power n minus 1. Now, you could leave your answer as that, or you could use your knowledge of indices to say 4 raised to the power 1 times 4 raised to the power n minus 1, and by the time you solve these two values, you'll be having 4 raised to the power n as your final answer, which is also a very correct answer. Okay, if you go to the second example, that's 1b, you'll find out that the first term is 3 and the common ratio is 2. And of course, by the time you slot the values in, you'll be ending with the answer 3 into the bracket 2 raised to the power n minus 1. The same thing goes for the third example and as well the fourth example. If you look at the third example very well, you'll find out that the common ratio is minus 3, because 9 divided by minus 3 is minus 3. If you want to check also to know if your common ratio is correct, you can say minus 27 over 9. You will still get minus 3. Okay, slotting these values into the formula you are given, you have minus 3 multiplying minus 3 raised to the power minus 1, and by the time you solve them using the indices, you have minus 3 raised to the power 1 plus n minus 1. At the end of the day, you will arrive at minus 3 all raised to the power n, which is the right answer for the nth term of that exponential sequence. Of course, the fourth one, you have 27, 9, 3, 1 and 1 over 3. This sequence is not like the others. Here you have a decrease, and that means that the first term is 27. The common ratio here is still the second term divided by the first term, irrespective of the value. Maintain that formula. The common ratio is always what? The second divided by the first. Why common difference is second term minus first. Note the difference. Okay. Okay, so we have the common ratio to be what? 9 over 27, and that's 1 over 3. We're slotting these values into the formula. We are going to be having our final answer to be 27 into bracket 1 over 3 raised to the power n minus 1. Now, on no account should 27 have anything to do with 1 over 3 at the moment. Why? Because 27 is on its own, while 1 over 3 raised to the power n minus 1 is on its own. Well, you could use some indices to solve that problem, and you will still arrive at 3 raised to the power 4 minus n. 3 raised to the power 4 minus n. Of course, you can make 27 look like 3 raised to the power 3, and by the time you solve the problem using one of the laws of indices, you'll be having 3 raised to the power 4 minus n. So your final answer can also be 3 raised to the power 4 minus n. You are still very correct. Alright. So I hope you enjoyed the video you watched, and I hope you are able to understand what I have taught you. Alright. Otherwise, you just let me know on the WhatsApp privately. You send your message to me so I can attend to you. Alright, so I'll be giving you an assignment right now. So you go to page 159, exercise 15.3 in your Cambridge IGCSE book, Other Education, the one you use in the class. So you go to page 159 and you do exercise 15.3. You do questions 1, 3, 4, 7 and 8. 1, 3, 4, 7 and 8. Those are your assignments. Okay, and as well, go to page 162, exercise 15.4. Page 162, exercise 15.4. You do question 1, 2, 3 and 4. Question 1, 2, 3 and 4. Okay, so as soon as you are done, send the answers to me on the WhatsApp. Okay, all right, take care.